So this is, in a way, the more complicated of the three examples. And this is basically, we have a ladder, so we say a 20 kilogram uniform ladder. So I'm just going to go, it's uniform, so from the middle of this, I'm going to put down 200 newtons, because it's a 20 kilogram uniform ladder. It's 8 meters long, so out here, I'm going to put down 8 meters, so that I get that. It's on the point of slipping. The ladder makes an angle of 60 degrees with the floor, so there's my 60 degrees with the floor. What is the force of friction between the ladder and the rough floor? So what I got to do now is I've got to take an inventory of my forces. He says there's a force of friction between the ladder and the rough floor. Will it point towards the corner or away from the corner? Which way will friction act at this point here? Towards the corner. The tendency for the ladder is to slip out, and so the force of friction is pointing away. What else? What other force should be associated with this point where the ladder touches the floor? There's going to be a normal force upwards. And then from the top of where the ladder touches the wall, what forces, if any, should be up there? Normal force pointing in that direction? What about a frictional force? Read the instructions again. Uniform ladder leans against a smooth wall. Smooth meaning colloquially no friction. It's not really true, but no friction, smooth, no friction. These days I'd like to have said frictionless wall. You know, that's the way it goes. What am I asked to find? Force of friction. Get your pens. I don't want Fn, and I don't want Fn. They're not the same Fn, by the way. We've got to give them different numbers. Where do they join? There. Oh, I get it. Your turning axis does not need to be in your actual object. Your turning axis can be like anywhere you like it. So there's my turn. Let's call this N1 and then N2. So we have it. Okay. So the sum of the torques about this green turning axis equals 0. So clearly I have a 200 Newton force, 200 newtons. Now, what is the perpendicular between this 200 Newton force and my turning axis? Can you give me an expression for it? It's going to involve the length of the ladder, and it's going to involve an angle. So what is my perpendicular distance? What is that distance? You can move it around. You can look at it in other parts. There's other parts of this thing have the same length. So it's going to involve the length of the ladder. You know that's 8 meters. No. It's got to have some length in it, and you're using the force. Forget the force. The force is 200. So it's going to. So 8 cosine 60. Divided by 2. Okay, yeah. Good. It's basically that distance there, isn't it? That distance there in green is that distance there in green, yeah. And that's a nice triangle. So this would be 4 cosine 60, and that's going to be tending to turn this thing in a counterclockwise direction. And I'll tell you now that people, that's positive, I'll tell you now that people get confused about that, and this is what you need to do. If you tend to get confused, you put your finger on the turning axis and you rub your hand in the direction of the force. see which way your paper kicks. And if it kicks that way, it's counterclockwise. If it kicks that way, it's clockwise. Because the problem is this force is not level with. If it was there, it would be pretty obvious that it's counterclockwise. But because this force is way down here, then it's not obvious. And so, and some people, it's hard to predict too, but some people just have a whole bunch of trouble with it. So my advice is you put your thumb on the turning axis and you run your, and you see, oh, my paper turned counterclockwise. And then there's no doubt about it. Let's change colour pen so you can see this second bit. Yeah, let's go to purple. And then let's say, well, what about, let's add on, what about our next force, our next torque? We've done the 200. We got to do, oh, the thing we want, of course. The thing we want is FF. So it's going to be FF. And what is the perpendicular distance between FF and my turning axis? There it is. How can I express that in terms of what I know?
8 sine 60.
Excellent. It's going to be 8 sine 60. Oops, 60. And is that going to be a clockwise or a counterclockwise torque? The force is going that way. And it's going to be clockwise, so that's going to be a negative equals 0. Oh, I just put it to the side. I thought I was going to put it underneath. So anyway, so then we say, well, that's going to be 800 cosine 60 minus FF times 8 sine 60 is equal to 0. So FF is equal to 800 cosine 60 divided by 8 sine 60, which equals 100, and a cosine over a sine is 1 over a tangent over tan 60. You don't have to know that trig. You can just work out what cosine 60 is and divide it by what sine 60 is. Yeah, you don't have to recognize that the cosine over a tangent, adjacent over hypotenuse divided by opposite over hypotenuse, is adjacent over opposite, which is 1 over a tangent. That's just a little bit of mathematical, kind of like, you know, oh, look, I just made a shortcut. You don't need that shortcut at all. And so we say FF is equal to 100 divided by the tangent of 60, which equals 57.7. Okay? And remember, play teacher. What else can I do? I could ask you for FN1. If I asked you for FN1, well, let's not talk about FN1 for a minute. Let's talk about FN2 for a minute. If I asked you about FN2, where would you put your turning axis? I want this guy. Where's my turning axis going to go? There. Now, if I ask you for FN1, well, I don't want that force, and I don't want that force. But I don't want that torque, no, but they never meet. So there's a bit of a, whoa, what do I do now? But think about it. Think about it. This is the second condition for equilibrium. Think about your first condition for equilibrium. What's the vertical forces in this problem? What's the other vertical force in this problem? Fm1. Don't they sum to 0? Just because the first condition for equilibrium. So Fn1 is a bit of a cheat. It looks like it's a torque problem, but you solve it using your first condition for equilibrium. You say, oh, the sum of the forces vertically equals 0. There's Fn positive plus 200 negative equals 0. Okay. So from a teaching point of view, you know, I'm going to give you a ladder leaning against the wall, or I'll give you a boom and a mast, or I'll give you a couple of things, you know. But it's not going to be this problem. It's going to be a problem. And you've got to, again, you've got to draw your diagram, and you've got to apply the technique. And the more you can see why I'm doing things rather than what I'm doing, the more you're on your own. You can just figure stuff out for yourself because you're looking at my approach rather than what I do. Okay? We'll do this next time. It's not a long bit, so we'll stop it there. So